Yeah, it's good to see you again, boss.
Good to see you too.
Yeah, but before we proceed, I would like you to just introduce yourself to our audience.
I'm Oz. I'm more or less the forefront consultant for the Create for Hope initiative. That's essentially that.
All right. Really short.
Yeah, very short. Because I mean, there's more to discuss down the line. So.
Exactly. Yeah. So my name is Martin Zodi. Yeah, I'm here to talk everything regarding design with Oz, as he's just introduced himself. We'll just proceed with talking about this. Also, I'd like to ask you, as a design educator, as a design and expert industrial designer, what is design?
Well, I mean, design has so many meanings. The basic definition is planning. So I need to know that in context to that, there's planning. And to the lay person, there is some elements of illustration and things like that. But from my perspective, the two things that comes into mind when it comes to design: to imagine and to realize. So to imagine is to have some form of mental construct, which is influenced by some form of prompt. So that prompt could be an existing problem or a vision that you want to bring bear. And the realization part is more or less how you make that transition. What process do you set in place to make that transition for that mental image to become a physical construct? So my definition for design is as follows. So design is a system of process or processes in realizing one's imagination to use some form of physical construct. And that's essentially how I would more or less define design.
Yeah. So, any further thoughts on imagination and realization?
Okay. Yeah. So we can break that down into the two key elements of that definition. So just to simplify it, design is the realization of one's imagination. Okay. So let's just take imagination. So what would that entail? So as I stated, imagination is that mental image. Okay. And that mental image will have to be translated physically on paper, so it needs to be mapped out or planned out. So there are at least 4 components to imagination. So discovery will be the first thing. So as I stated, there will be something that will prompt that mental image. So it could be something more external, so a problem that's been seen and that then processed to become some form of mental image as to how that mental image could more or less render some form of solution to that problem. So discovery, exploration, and the exploration part also lends itself to finding out various ways to go about finding some form of resolution to that problem. Then you've also got the empathy bit, or to empathize. So this is where you now factor in the human element. Okay, so how well will that solution fit the intended end user or the person that you're trying to define some or to establish some form of solution towards. And then the last part will be, okay, now that you have some form of clear mental image, how do you then go about capturing that on paper? So this is where you start to ideate, this is where you start to generate ideas. So once you're more or less happy with whatever you've imagined and how that imagination has now been visualized on paper, then the next part will be, okay, what process you set in place to make that transition from something mentally to paper, then to become something more physical construct. And this is where the realization bit comes into place. So the realization will constitute things like, okay, what form and what shape would that particular idea embody, then you can move on to that. Think about, okay, what are the technologies that need to come together to yield that intended purpose or function? Then once you've established that, then you now need to think about, okay, what are the materials, what are the resources to yield that? What are the manufacturing processes available that can yield that net form that you really want? And what are the layouts in the work, and what's the architecture that one needs to have to make it easy for the end user to engage with? Then you then proceed to make and test the idea. So that's essentially the two key words that define design for me.
Brilliant. Thank you so much. Yeah. So let's move on to the next question. So, what are the various components of design? I know you've mentioned realization and imagination and realization, but then I know that there are various components.
Yeah.
Do you want to let us know about that?
Yeah. The various components, I tend to group them into three groups or three categories, which I would call the Trinity of design. So you've got engineering design, you've got industrial design, you've got ergonomic design, or if you want to call it user-centered design.
Okay.
So these are the three key areas. Now, I do realize that I haven't really mentioned product design, but for me, product design is kind of like the subset of all these elements. So I wouldn't necessarily, put that in as part of the Trinity, because it's more or less a hybrid of different elements, and the bias will be dependent on what the person's interest is. So let's put product design on the side and let's focus on engineering design. So engineering design more or less focus more on how a particular product idea is supposed to work, what are the technologies that need to come together to yield that intended purpose, and the measure of the performance in that regard. So that will more or less be the engineering design bit. So it focuses more on product functionality. The industrial design focuses more on the packaging. So how do you package the product for market and for manufacture? So the industrial design part focuses more on the aesthetics of the product and how it can be packaged for manufacture. So that's essentially what industrial design is. The thing that marries the two is the economic design. So this is where you now need to put the user or the end user at the heart of the design process. Because what's the point of designing a product that has optimum functionality, that has excellent aesthetics, but the user engagement is very, very poor? So you do need to have an understanding in terms of how the product impacts on the user in terms of the biomechanics, in terms of the psychological element too. Because again, there's also an emotional element to it in terms of how the user will engage with the product to ensure that the product is used over a longer period of time. So these are more or less, the elements that for me constitutes design.
Yeah, just hold on with your thoughts. I would like to take you back to the bit where you talked about product design.
Yeah.
So I know there's this debate about product design and industrial design. What is really the difference? I know a lot of people will be watching this now, and young engineers, intended designers, they would want to know what is really the difference. Could you say, just to prompt, could you say that the industrial designers consider more the manufacturing process in addition to the packaging? Of course, that also leads to how the product is presented, and
Yeah.
the product designers don't. Is that what you would say?
Yeah, I think when it comes to product design and industrial design, and these terms seem to be used interchangeably, depending on what environment you're coming from. In terms of the culture in Lethbridge University, you can draw that distinction in terms of what the specialism is or what is the focus. So industrial designers tend to focus more on creative form and how those creative form can be packaged for mass production or batch production, whatever you want to call it, towards a particular market. Whereas with the product designer, they more or less approach design from a more scientific perspective, as opposed to an industrial design that focuses more on an applied artistic perspective, if you put in that context. So with the product designer, they tend to be a bit more biased by applying engineering methods in iterating and using prototypes to iterate, towards a solution. So it's a bit biased towards, engineering design, but it's not really there.
So there's no focus on the packaging.
There is focus on packaging. That's why I said that there is a bias, because again, depending on what the specialty is, someone could be a product designer with more emphasis towards front-end design. Someone could be a product designer with much more bias towards back-end design. So more focused on the development of the product rather than the front end of it.
All right, thank you for clarifying that. Let's see what engineering design is about. Really, when you talk about engineering design, what constitutes engineering design?
Well, when it comes to engineering design, it's more or less a hierarchy of what is significance. So what are the most significant things, that a typical engineering designer will really focus on. So, as I stated, the core of engineering design is understanding how a product is supposed to work and what will be, the performance that will govern that functionality. So that will be, the top priority. Followed by that will be the reliability element too, because again, all right, it works great, but over time, how long can that function be sustained? How long can that performance be sustained over a period of time, depending on what the defined life cycle of the product needs to be. So there has to be some understanding in terms of understanding the reliability of the technologies that's coming together to yield that function. Then once that's done, you also need to think about the human factor element too. So human factor engineering. So again, this is where you need to think about, okay, in terms of the architecture of the product, how easy is it for the product to be engaged by the user? So even though it's not the top hierarchy or the top elements within that hierarchy, it still needs to be considered. Because again, the product will have to be used in a certain way. It will have to be maintained and serviced in a certain way. So you do need to understand what these implications are in terms of how the product will be used and the impact of usage on the end user. So you've got that element too. You also need to think about, the materials too. So material conformance will also come into play. So again, depending on what type of performance you want from the product, depending on how you want the product to function in terms of its kinematic behavior, it still needs to be dictated by the materials that you choose. So if the material is not durable, then your product is more or less going to fail very quickly. So you need to understand the implication of the materials that's required in fabricating the needed components in yielding that particular functionality for that product. So that needs to come into play. However, you also need to factor in the implications of the material choice to the fabrication processes. So that also becomes, an element too. While saying that, you also need to think about the engineering aesthetics. So we'll talk about that later on. Because again, whatever function that you intend for the product, it still needs to have some form of form. So that needs to be taken into account. Manufacturability is also important because again, you need to ensure that you're designing the product in a manner that you can realistically make it based on the technologies that exist or the processes that exist. Then the last part will be validation. So this is where you need to test and prove that the product is more or less conforming to what you've more or less specified
Yeah.
during the front end part
Yeah.
of the process. So these are the things that will more or less be the hierarchy of significance for a typical engineering design.
Interesting.
Yeah.
Thanks for that. We've had all this. We've spoken a lot about the various the hierarchical complexity in the engineering design. So let's look at industrial design. If somebody who wants to be an industrial designer, what really should they keep in mind?
Okay. So when it comes to an industrial designer, and we're looking at the hierarchy of what's important. Now, someone used this analogy that industrial designers, work from the outside of the product, looking inwards, whereas it's the opposite for an engineering designer. We tend to look at things from the inside, working out. So, because you're looking at the outside, you're more focusing on the form. So, okay, how can you go about enhancing and packaging the form for market? So it gives you that, opportunity to be quite adventurous in terms of what form a component or a product should take, and whether that form is ideal in terms of the end user. So aesthetics is more or less priority. Then material compliance, again, you need to think about, okay, does the material have the needed properties to yield that particular form? And things like that, which also will bring into two elements too. So again, the usability, so how the user will engage with those forms. So again, if that form is going to make, product handling and product portability an issue, then that's something you need to really think about. You also need to think about, are the technologies available in yielding that particular form. So these are some of the things you need to think about. So as an industrial designer, it's not a situation whereby you provide something that's too abstract, that's not pragmatic. You need to think about how practical these forms are realistically, and whether these technologies are out there, and what you can do to ensure that these forms can be realistically manufactured. Then you also got the other bit in terms of sustainability. So responsible design is a key factor in the heart of designers. You shouldn't just be designing for the sake of designing. You need to think about what the implications are, not just to the environment, but also to other socio-economic drivers. So it's very important that you need to think about that. So once you've done that, they can start thinking about, okay, function. So what's the product supposed to do? Do we have the technology? Are the technologies out there, to yield that particular intended outcome, and the technologies that are available? So that will more or less be the hierarchy. But as I stated, there's always going to be a bias dependent on what your specialism is likely to be. So some people will more or less be interested in the front end design bit, so that gives them much more of a bias towards the applied arts, whereas some people prefer the back end bit, product development, so that gives them that engineering bias. So as I stated, it's quite fluid in terms of what industrial design is, but the heart of it, in terms of its meaning, is more about understanding product packaging towards market.
Okay, thank you for that answer, response rather. Let's get to ergonomic design. So you mentioned user-centered design. Are these terms used interchangeably, or is the user-centered design a subset of ergonomic design? Just clarify.
It could be, because again, user-centered design is very, very broad. It's very broad, but the key element is the user. The user is considered as as the central or the critical element when it comes to design. So that's stated. You can design a product with excellent functionality. You can design a product that's been packaged excellently. However, if the user is unable to engage with the product, then that's a big issue. So when it comes to user-centered design, there are a number of components. So there's the physiological elements of this. It's more or less the the biomechanical elements of it. So how the product is compatible to the user in terms of the user's physical dimensions and things like that. So there's that element that needs to be factored in. So again, when you're designing products, you can't design and cater towards everyone. There is a percentile they need to streamline the design towards. If that's the case, then what is that percentile? And have those, has that data been captured and influenced in sizing and planning out your design. So that's something that's quite critical. There's also a psychological element in there too, which will fall under the banner of cognitive ergonomics. So when you are designing a product, you also need to factor in that you've got different demographies, different classes of people with different educational backgrounds and things like that. So when you are designing a product, can the product communicate its use? So these are some of the things you may want to think about. How can the product, engage the user in terms of its operability? How can the product, draw out that emotion to cause the user to utilize the product over a period of time? Because one thing you don't want to do is for there to be that disengagement with the product, to cause the user to discard the product.
Yeah.
But that becomes an environmental issue too. So you want products to be used over a longer period of time. So these are some of the things that will come into play. There's also another component called, design for happiness, and that's another area that's being explored, whereby it looks at it's kind of like part and parcel of the emotional elements, but you're also looking at some amounts of emotion being brought about the user in terms of assisting their well-being. So there's that element too. You've also got the human computer interaction element too. So this is where experience and user interaction comes into play. But this is where you now need to think about, okay, if your product's got some form of user interface, what will be the right hue combination, what will be the right location, what will be the sizing of the control panel, what will be the amount of effort in engaging in the operational buses and things like that. So you need those elements too. And you've also got the operational and safety elements too. So at the end of the day, the product should be safe to operate, and it's going to be operated over a long period of time. Is that going to cause global localized strain? So repetitive strain injury and things like that. Is that going to be a factor over time? And if it's going to be a factor over time, what are the elements that you can more or less factor into the design to ensure that that doesn't occur? These are some of the things that need to be thought about. Then you also got like time and motion studies and things like that, which focuses a bit more into period of use, how the motion imparted and engaged in the product by the user will more or less influence how the product should be designed. So these are the elements that will constitute user-centered design. So there's been that argument that user-centered design is more or less the heart of design, which there is an argument for that. Because at the end of the day, you're designing for
humans.
Exactly. So
to provide solutions to problems. Yeah, thank you. Yeah, that was really enlightening.